Okay, so now who can Kai An answer this? Minh Hong answer this. Mita answer this. Wan Cheng answer this. Wei Dong answer this. Kai An again. Minh Hong again. Wan Cheng again. Oh, Wen Zhen. Kai An, you are correct. But actually, a distance could be a base or derive, then scalar or vector. Okay, Wei Dong is derive and factor. Wen Zhen derive and scalar, correct? Okay, I think you might forget because so long time you cannot answer. Derive and scalar, base factor, base scalar 2. Minh Hong factor, base or derive? Minh Hong, base or derive? Wan Cheng factor and no, displacement is base. Wan Cheng, yeah, it's derived. Minh Hong, energy. Okay, base quantity means the basic. Derived quantity, for example, this. All of this. Area, volume, density, velocity. Scalar quantity means only magnitude. Only magnitude means numbers. 1, 2, 3, 4, 5 only. Vector got magnitude and direction. Okay, so Minh Hong, energy is base or derived? Okay, energy, no, it's derived because energy actually is work done. Work done equals to force times displacement. Force times S displacement. Force times distance or displacement. Then it is scalar. Yeah, we no need count the direction. Energy acted on all direction. Okay, displacement actually same as distance is S and S. Speed is V and V, but one is scalar, one is vector. Both of them are derived, but speed scalar, velocity vector. Okay, so jot down already. You must jot down the meaning here too. Jot down the meaning here. Maybe you write example like bagus. Derive. Base. Here base. Yeah. Basic means this lah. Basic. means all of this. Okay, so scalar and vector are scalar only magnitude. This one got magnitude and direction. Okay. So normally this is objective first questions. They'll say, which one is scalar quantity, which one is base quantity, which one is derived quantity. They won't ask all of this together. They just ask one type of quantity. Okay. Now, scientific investigation about the graph. Okay, so we can see here. This graph shows what? Right? Minh Hong, number 2. Yeah, this is number 3, 4, 5, 6, 7. One chain, Smita, Wenjen, Kai An, one chain again, Smita again. Wei Tong. Yeah, Wenjen, very good. This is y increases with x. This is also okay. First, Wei Tong wrong. Wei Tong cannot say inversely proportional only. Cannot. Yeah, one must be like that. Y inversely proportional. Inversely proportional to x. Oh, you write the full sentence. Proportional to x. Mean the y increases. Yeah, y increases linearly to x. Hey, I did something wrong. You all change this. This one going down. Straight line going down. Straight line going down. Straight line going down. Wait, don't you lazy person, you. Okay, wait, this is y is directly proportional to 1 over x, or could be this. y is inversely proportional to x. Okay, so both of them, for this one is y inversely proportional to x. Y is inversely proportional to x. And this one is y directly proportional to 1 over x. Okay, this one we have learned in Form 4 before, but I believe you might not be able to remember already. Yeah, Ming Hong agree with you, y equals to x. So the relationship, you must say y directly proportional to x. Okay. Yeah, so unchained, this one is y decreases linearly to x or with x. Wei Dong cannot be lazy, y and 1 over x. You must write in front and after, in front and back. Okay, so number 4 and 5 actually is, yeah, 4 and 5 also the same. Y increases with x. But the difference is normally Form 5 won't ask this. Maybe the next level, the difference is here. Look at the gradient. The gradient increases. Then this one, look at the gradient. The gradient decreases. So y increases with x. Or maybe we write 2x. 2x. 2x with increasing rate, and y increases to x with decreasing rate. Okay, so here got a few graphs. Most of the graph we use is this. 90% of the graph is this. Then 10%, no, around 8%. 8% is this two. 2% is this one. Sorry, 2% is this one. All right, so that's chapter 4. And then we already know gradient of the graph. Y equals gradient equals to y2 minus y1 divided by x2 minus x1. Area under graph you all already learned in maths. Extrapolation, interpolation also we learned already. Extrapolation is like this. Charles' law. Temperature in degrees Celsius, volume in centimeter cube. Then we extrapolate. We get negative 273 degrees Celsius. And if you have done all, give me a green light. 1, 2, 3, 4, 5, 6. All right, next, now look at chapter 2, form for chapter 2. Okay, so this one, normally exam formula is number 1, number 2, number 3. This one not provided, not given in exam. And normally this 3 is enough already. Okay, Minghong, I want to ask, what's the difference between speed and velocity? Both of them are v, but what's the difference? Yeah, velocity need to count direction. Speed no need. So we say velocity is a vector quantity. This is a scalar quantity. Yeah, very good. So graph later lah. We look at momentum first. Later I want you all snap the picture and send as homework one. Okay, free fall acceleration is 9.81 meters per second per second. Newton's first law is inertia. Second law is F equals to ma. F equals to ma. You can jot down inertia. Third law is action reaction. We can say F equals to negative R. Action reaction. Action is F. Reaction is negative R. Right, second law is about force. F equals to ma. From our previous class, I tested you all can master already. May need to practice more. Make it as an exercise for you. Okay, so momentum is principle of conservation of momentum. Then we will see here again. Then impulse is Ft equals to mv minus mu. Impulsive force is F equals to mv minus mu over t. So the difference is impulsive force got t at the bottom, so we say the rate of. But this one just the change of momentum. Okay, now principle of conservation of momentum means this is SPM 201 2016. Okay, so we say what is, when they ask what is conservation of momentum, we say total momentum before equals to total momentum after. Now done already. So there are three types of collision or explosion. So we say M1U1 plus M2U2. Left hand side means before. Right hand side of the equal is after. Before, after. Inelastic means they stick together, so they share the same V. Explosion. Before this, they are stopped. So total momentum for left hand side 0, right hand side also 0. Means these two objects move in opposite direction. Okay, so normally this will exist in objective questions. They ask you, let me check. Form 1, Chapter 4, Chapter 2. Impulse, graph, electric force. Okay, so if impulse, we can use F times T, we can use mv minus mu. And impulsive force, remember lengthen the collision time. Yeah, I missed out the momentum. I didn't save this. Okay, never mind. Most of the time they will ask is total momentum is 0 for explosion. Okay, then next. Oh, graph. Okay, so now the displacement time graph, velocity time graph. Okay, look at velocity time graph first. Okay, from this graph, how can I find displacement? Ask me that. How can I find displacement? You can draw this up. Then tell me how to find displacement. Smida and Kaian, tell me how to find displacement. Yeah, Kaian, correct. It's area under graph. Okay. Because area under graph is so this is T and this is V. So S equals to V times T. It comes from V equals to S over T. So if we use V times T, then we will get area under graph. So it's displacement from VT graph. Then how to get acceleration? Smita and Ming Hong, how to get acceleration from the graph? Ming Hong and Smita. Yeah, Ming Hong. So acceleration is gradient of the graph. Gradient here would be V2, V1. Then here would be T2, T1. So gradient means v squared minus v2 minus v1 divided by t2 minus t1 means v over t. So v over t is acceleration. Now get it? Mình không get it. Yes. So you may make a small note here. We can draw three graphs. ST, VT, AT. V, straight line, constant. So if we want to find the next, like S1 to find T, S1 to find V, V1 to find A, we use gradient. Okay, then we want to find back A, get back V, V get back S, we get area under graph. Okay. I should put one question here. One question. Let me check. Do we have questions? We don't have. Yeah, we don't have. All right, so next. This one piece of cake lah. Okay. Then next, gravitation. We got 1, 2, 3, 4, 5, 6, 7 formula. I think will be given in the exam. So T1 square over R1 cube equals to T2 square over R2 cube. Okay, this is Kepler's third law. First law is saying all of the planet surrounded the sun in eclipse form. Then Kepler's second law is the area will be equal when it sweeps from the sun to the earth. Can I remember this? Do I need to explain in diagram to help you recall? This one. Yeah, I should put this inside. Okay, first law say the orbit are ellipse. Then the sun is on one of the focus ellipse. Second is equal areas in equal time. When the Earth travels far away from the sun, it will move slower. But when it's close to the sun, it will move faster. So the area sweeps from the sun to the Earth within 6 months for closer distance or further distance away from the sun, the areas are the same. The areas are the same. Then this one is t squared directly proportional to r cubed. This one should be r cubed. Okay, so it's because of the trigonometry method, but now you just know how to use t1 squared over r1 cubed equals to t2 squared over r2 cubed. Maybe you can print this out and paste it inside. I'm sorry, sometimes when I go through it, I don't have idea. But when discuss with you, suddenly the idea comes up. You're drawing it. Okay, drawing lah, draw lagi bagus. Draw lagi bagus. Okay, draw lagi bagus. If I have done, tell me. Three objective questions only. I don't get it. Number 3. Okay, so we got Form 4, 6 chapter, Form 5, 7 chapters. Then we got 40 questions. So we got 13 chapters. So 40 divided by 13, we will get 3 questions. Yeah, 3 questions. Correct lah. Yeah, I'm correct. One chapter will have around 3 questions. Every chapter will have objective questions. So one chapter, 3 questions. Okay, done already? Done already, continue. Normally 1, 2, 3 is 1, 2, 3 is number 1 is the most used. Then for me, I will set 1 questions from this formula, second questions from Kepler's law, third question from either linear speed or escape velocity. So 1, 2, 3 questions. Happy. Okay, so jaw satellite means 24 hours. Okay, means always on top of one zone. Okay, always located above a zone. What is uncle? Cảm ơn em, thu rồi. Okay. Okay, so now next we look at chapter 4. Okay, chapter 4, thermal equilibrium means net flow of heat is zero, same final temperature. Okay, then Ming Hong, tell me what is specific heat capacity? Okay, I know C equal Q equals MC theta. Q equals MC theta. When I ask you what is specific heat capacity, I'm asking you to define specific heat capacity. So I jot down here already. Specific capacity equals to C equals to Q over M theta. So the three keywords is heat needed, 1 kg, 1 degree Celsius. So the definition is here. Definition. The amount of heat needed to rise 1 kg of mass in 1 degree Celsius. Okay, so Ming Hong, get it? The three keywords here. Ming Hong. Ming Hong. Can you can say in that way, correct? Okay. But if you say in this way, we can't give you 1 mark because the SPM schema, we must check the three keywords. Heat. We see heat. We see 1 kg. We see 1 degree Celsius. Because 1 kg actually refers to the words specific. So specific means 1 kg. Okay, so you say rise the temperature. For physics, we need to be more accurate. So we say raise 1 degree Celsius of 1 kg of mass. If you answer like this, 3 keywords in a sentence, then only we get 1 mark. Okay, so must mention 1 kg of mass, 1 kg of substance, and must mention the numbers 1 degree Celsius. Alright, Ming Hong. That's why I bolden heat 1 kg, 1 degree Celsius. We must have these three keywords. Ming Hong, okay or not, Ming Hong? Alright, so now latent heat. There are two types of latent heat: fusion and vaporization. So actually this heat is needed to change 1 kg of fusion is solid to liquid. Then vaporization is liquid to solid. Yes, very good. Liquid back to solid is also fusion. So, yeah. Thank you, Waiton. I blur case liquid to gas. So gas back to liquid. Blur sotong. Blur case. Thanks, Waiton. Blur sotong. Gas. Okay, the 3 keywords for latent heat. Since we got specific, means we must have 1 kg. Specific means 1 kg. So heat 1 kg temperature. But this one we need to tell liquid, solid to liquid or liquid to solid, constant temperature. Okay, so we must mention temperature too. Temperature too. Okay, then look at this boiling graph, heating graph. So A to B, you can see that it will be total solid. B to C is solid and liquid. C to D is totally liquid. This one we have learned in our chemistry. So D is liquid and gas. This is totally gas. All right, so next here, because there is increasing of temperature, so the Q here is MC theta. The Q here is MC theta. Then because here don't have any changes of temperature, so the Q here is Q equals to ML. Then the Q here equals to ML. So what is Q? Q is heat energy. So Q is heat energy. And don't confuse with from 5-1. Q could be heat energy. and Q equals to IT, or maybe Q equals to MC theta is heat energy, and Q equals to IT is charges of electricity. And then from here, Q, since Q is energy, so normally if we use kettle got power, let's say 1000 watt. Kettle, let's say 1000 watt. So we can say that the electrical energy equals to PT. So we can say PT equals to Q, so PT equals to MC theta. Okay. Yeah. Okay, so now 270. Oh yeah, 270. Okay, so now hey. The case again. The 273. The case again. Theta plus 273. Thank you, Kai-en. Okay, so now next one, this is Kepler's law, which is P1 over T1 equals to P2 over T2. This is Boyle's law. P1 V1 equals to P2 V2. Then this is Charles' law. V1 T1 equals to V2 T2. So we cannot simply use proportional method. If Gay-Lussac, okay lah. Gay-Lussac and Charles, okay lah. But Boyle's, we cannot use proportional method. Okay, so when we see they say some air, some gas lah, volume, temperature, something changed lah. Please draw back the triangle and check back the law. Okay, so the whole chapter I feel quite easy. Just the calibrated thermometer might be a little bit hard if you forget. And this one, if Q1 equals to Q2, then MC theta equals to MC theta 1, 1, 1, 2, 2, 2. Then this one might be a little bit difficult. All right, next. Okay, chapter 5. Oh yeah, I forgot to put on to transverse wave and longitudinal wave. Well, never mind, we look at the formula first. B equals to F lambda, F equals to 1 over T, so T equals to 1 over F. Okay, T is period. T is the time taken for one oscillation. Then reflection of wave is V equals to D over T, because the wave traveled to and traveled back. Travel to and travel back. So D will equals to Vt over 2. So now lambda equals to Ax over D interference. Wait on. What is A and lambda? One chain. What is X and D? Wait on, one chain. X is distance between two antinodal lines. Good. Wavelength. Wavelength actually is distance from crest to crest. If this is a wave, this is crest, this is crest. Crest to crest will be lambda, okay? Wait on. A is distance between two coherent sources. Two coherent sources. D is distance between sources and screen, or X. Now D is here from source to the screen. You can see that. X is antinodal to antinodal. Lambda is crest to crest. From the wave crest to the crest of the wave. Okay, then what is coherent source? Lai Wenzhen, what is coherent source? Two coherent sources. What is coherent sources? Yeah, Wenzhen. When two sound waves interfere with each other, it's called interference. Coherent sources means the two sources, one, the first source and the second source, 1, 2. Yes, we don't. The 1, 2, both of the sources, have same frequency in same phase. Same phase means same position and time. Phase means time. Means the two waves, they meet each other on the same time. They meet each other. Okay, so these two called coherent if they have same. Maybe you just write the shortcut. Same frequency, same phase, right? Oh, one more. They would ask about what is monochromatic light? Lai Ming Hong. Monochromatic light. Ming Hong, what is monochromatic light? And we don't. What is monochromatic light? No. Okay. Mono means one. Chromatic means one color or one frequency. Okay. Then monochromatic light could be the coherent source of the interference. Okay, then this series can memorize already. Must memorize. All right, so here you can, let's say this is the interference pattern of red lights. Not red light, green light, green light. You can draw an interference pattern for green light. Okay, now, so this is the x. X means from a nodal line to nodal line. Then how if I change to red light? I change the monochromatic light from green to red. What will happen to the x? What will happen to the x? Like everyone, please answer. What will happen to the x? Yes, Kai An. Yes, very good. Everyone, Kai An. Wenjin, yeah. Wenjin. Okay, the answer is increases. Okay, answer is increases. Okay, why? Because F equals to V over lambda means F inversely proportional to lambda. Or so we say from green to red, the frequency decreases, but wavelength increases. So we say that lambda equals to AX over D. So since lambda increases, X also will be increases because from this formula we will get lambda directly proportional to X. So from green to red, lambda increases, X increases too. Okay, so this one, normally when they ask about interference, sure they will ask if green light change red light, green light change blue light change red light change blue light, something like that. Then sure got one question like this, sure. Right, so next we look back to diffraction. Diffraction is when lambda increases, diffraction will be more. Slit size decreases, diffraction will be more. Okay, so now next, the last slide. Then the rest we discuss next week. Oh yeah, may I get Wenjun, may I get your school questions? Can you send to my WhatsApp so that oh, thank you. Then we let Taman C students do, and you do Taman C questions. Did I give you this month test? Oh, Wenjun Weitong, have you done the Form 5 test? Wenjun, yes. Weitong. Oh, good. 32. Weitong. This one, Weitong. There's the way, okay. So, okay, the last is light and optics. I'll make this as a revision class for next week. Next Monday night. Okay, so if you want to come, also can same link. I will just, because many people, for my school students, many people doesn't go through this ray diagram drawing. So I will have a class on next Monday. So Ming Hong must join. Can't access, so there will be answer in the form. Can. I will record. And post in YouTube. Easier. You can't access the original one. Oh, there will be answer in the form. Oh, never mind. You give me the empty one also can. All right, so last refraction of light. Snell's law is n equals to sine I over sine R. Oh, okay. Then see lah, Wenjun and Weitong, your school. You check your email if you can get to send to me. Then Jin Er's one is VU3. We also can get one set from him. Right, Snell's law, sine I over sine R. Speed of light in vacuum, speed of light in medium. So the sine I over sine R must be always from less dense to denser. Less dense divided by denser. So no matter how, less dense divided by denser one. Okay, so now can you tell me what is this refractive index? N equals to sine. So N equals to 1. Okay, so answer is 1.29 or 1.285. 85 is it? 286. 1.286. 1.286. Haha, gonna debug. Because I is angle between normal to the incident ray 40. Here is 90. Normal means 90 degrees. R is from normal to the light ray. So it's 40 over 30. Sine 40 over sine 30. Okay. Now, what is the refractive index of the water? I can give you a hint. N equals to real depth over apparent depth. Answer. Substitute answer. And I can remind you depth means from surface of water to object or image. So from the real depth is from the surface to the object, 5 cm. Apparent depth is here, 3 cm. From the surface of water to the image, 3 cm. So 5 divided by 3, 1.67. 1.67 C. Okay. Depth is from surface, go down. Height is from bottom, go up. Okay, so depth is from surface goes down. Surface goes down. Can get it, height and depth. Okay, then the rest is must refer to the ray diagram. Then a little bit calculation. Okay, so it stops here. And 2015. Here. Okay, 2015, please do number 9 only. Okay, the homeworks today, number 9 only. Please do it on the test bed. Okay, so up to here only homework 2015 number 9. Any questions? You can stay back now. If no, then you can rest now. Thank you, class. Bye.